Let us understand how we can quickly get schema using one file and apply on other files. We can pass the file name pattern to spark.read.csv and read all the data in files under HDFS public airlines all airlines into data frame. We can use options such as header and infer schema to assign names and data types. However, infer schema will end up going to the entire data to assign schema, which means to assign the data types for the columns. We can use sampling ratio to process fraction of data and then infer the schema. That is one way of taking care of it. In case if the data in all the files have similar structure, we should be able to get the schema using one file and then apply it on others. In our airlines data, schema is consistent across all the files, and hence we should be able to get the schema by going through one file and apply on the entire dataset. Let's make sure we have right kernel here. Let's run this to actually create Spark session object. Then we can actually scroll down here. We should be able to get data from one file using this approach. In this case, I am saying spark.read.csv. I have passed one file to it as first argument. Then I am saying header equal to true and infer schema equal to true. It will create a data frame, and the data frame name is nothing but airlines part 00000, which is 5 zeros. Let's run this and let's create the data frame by name airlines part 5 zeros. Once the data frame is created, we should be able to use type to actually validate the type of this object. You can see it is of type data frame. You should be able to preview the data by saying airlines part dot show like this. You can actually see the 20 records. You got the column names, header, and then you should be able to see the data. If you want to validate the schema itself, there is a function called as print schema. You should be able to use print schema, and you should be able to see the schema details here, which are nothing but column names and data types. You can see that column names are inherited from the header of the file, and the data types are inherited based upon the data. We have seen that airlines underscore part underscore 5 zeros is of type data frame. A data frame contains an attribute called as schema. You can actually get the details about that attribute by running this. It is of type structure type, and it have all the fields that are there as part of our data, which is nothing but this one. When I say print schema, it just provided the preview of the schema, but the actual schema is defined like this. You can also get the type of this attribute by saying type of airlines part 5 zeros dot schema. Now you can actually directly apply the schema on top of our CSV function call instead of creating intermediate data frame like this. So this will take care of creating the schema by name airlines underscore schema. Let's run this and then let's say type on airlines schema, which is nothing but structure type. So instead of creating a data frame separately and then getting the schema, we are directly using schema on top of CSV function call, where we will be getting the schema for our purpose. Now, if you look at the help on spark.read.csv, either by using help function or question mark if you are using Jupyter based environment, there is a keyword argument called as schema for CSV. If you go to the details about schema keyword argument, it says it takes either argument of type structure type or of type string, and the string has to be DDL formatted string such as this. Now, as the schema is of type structure type, we should be able to pass this. So the way it will be is like this. If I scroll down here, we can say spark.read.schema of airline schema, then CSV, then we should be able to pass the path under which we want to process the files with header equal to true. That way header will be ignored. Either we can use the schema like this, or we can also use the keyword argument. So we can say schema equal to airlines schema like this. Either of the approach will work, and they will discard the header, they will process the rest of the data, and they will apply the schema that is passed as part of the keyword argument schema, or even using a schema function on top of spark.read before invoking the CSV. Using either of the approach, we should be able to apply the schema on our data. Let's run one of these. I'll be running this one. Then we can actually get help on airlines. It is of type data frame. It will actually provide us all the APIs that are available. Before running the count, we will actually run show as well as print schema, then we'll actually run the count. So let me say airlines.show and then airlines.print schema. Now the data frame is created by name airlines. You should be able to get the help on airlines. There are a bunch of APIs that are available. You can go to the details. You can also say airlines dot and hit tab. You should be able to get the functions that are available on this data frame. You can see the details here. We'll go through some of these as we proceed further and understand how the data can be processed. For now, you can actually preview the data by saying show, and then you can actually print the schema by saying print schema like this. You can see the data as part of the show output and then schema as part of the print schema output. Now we should be able to get the count. This will take a while because we have 1921 64 MB files. It is quite big. I think it is of size 120 GB, and hence it will take time, and we'll be getting the count. The count will be pretty high. We will be running this again at a later point in time, and hence for now I'm just stopping this so that we don't have to wait until it is run completely. But the number of records in this is pretty high. We'll understand when we get into further details, and we'll take it further. For now, we have understood how to infer the schema on even a larger dataset. First, we need to get the schema using one of the file as reference, and we should be able to apply that schema on the other files to create a data frame of the entire dataset irrespective of size of it. Also, we have something called as sampling ratio, which can be leveraged to get the schema applied faster on our large datasets while creating the data frame. Otherwise, just to create the data frame will take quite a lot of time if the dataset is quite large, if you use infer schema to infer the schema based on the data.